Okay, so today we're going to be talking about how to prepare samples for SDS-PAGE. So you all know basically what a gel looks like. So it's going to be something like this, where you've got these wells. That was kind of small. So you can sort of see that each well is same height, and I'm not doing a very good job here, but you get the idea. Okay, so your protein is going to go in here. Usually that amount is about 50 microliters. So that's the same as 50 times 10 to the minus 6 liters. Okay, so that's really important, so we'll just remember that. So now when we're working with proteins, I'm going to change the color here, we need to know certain things about the protein. One is going to be the absorbance at 280 nanometers. And this is what's going to tell you the concentration of the protein. We use something called Beer's law. So that's basically the absorbance equals the extinction coefficient times the path length times the concentration. Okay? And so if we know all of these numbers, then we can determine the concentration if we solve for C. Okay, so we do our absorbance reading and say the absorbance is going to be 0.9. Okay, and so if we want to know the concentration, then we need to know the extinction coefficient and the path length. And so if we know that, we get a number. And so that factor, we're just going to call that the F, or we'll just say factor, is going to be 1.7. So that's just an example factor. So 1.7 is the absorbance at where the protein concentration is 1 milligram per milliliter. Okay? And so in order to take the absorbance and get to that number, we just take that absorbance, 0.9, and then we divide it by 1.7. Okay? And so if we go down, I'm going to open up my calculator. So I'm going to bring that up. Okay, bring that over here. So we've got 0.9 divided by 1.7. And that is 0.529. So let's just write that down. Okay, equals, we'll just change the color here, 0.529. What are the units of that? So that's going to be in milligrams per milliliter. Okay, so that's the actual concentration. So really useful information to know. But we want to go a little bit further, and we want to basically take that protein and run it on the gel. And so what we're looking for when we run on the gel is if we don't have a lot of protein, it may just be very light. You may not see much at all. If we have a large amount of protein, you may see your protein of interest, but it's just really big. It kind of even goes into the other lane sometimes. So what we want is just a nice, sharp band. And in general, this doesn't always apply, but you can usually use about 10 micrograms of protein in order to get to that level. So how do we calculate 10 micrograms of protein? And so what is that? So that's 10, so I'll do E to the minus 6 grams. So not a lot of protein. So what we do is we take that number, 10, and then we're going to divide that by the concentration. So this is in micrograms. We use that Greek mu for micro. We need to divide that by the protein concentration. So it's going to be we're going to just say 0.53, and that's going to be micrograms per microliter. This is a good distinction. So originally we had mgs per mil. Now we're changing that to micrograms per microliter. And what that's going to allow us to do is these are going to cancel out. This is going to move up here to the numerator, and we do that math again. So we'll go back, pull up our handy dandy calculator. So we've got 10 divided by 0.53, and that's going to be 18.86, but let's just call that 19, and it's going to be microliters, or 10 times 19 times 10 to the minus 6 liters. All right, so now we know we need 19 microliters of our protein solution, that's 0.529 mg per mil, to get 10 micrograms. Now we want to load 500 microliters into the well, or sorry, 50 microliters in the well. So we have 19 microliters of our protein, and we also need to add a dye, and this is a, let's change the color again. This is a, let's see, sorry, 5X dye. So what that means is for every 4 of our sample, it's a ratio to 1 of the dye. So if we have 50 microliters, so that's really easy. We need 10 microliters of dye. And then it's just simple math. So we're going to need 21 microliters. In this case, we just use water. And so that's going to be 50 microliters total. And then that's what we're going to run on the gel.